All right, let's continue. So we have absolute value function and piecewise function. I have the graph of this absolute value function. I want you to write the absolute value function in piecewise function. So this is how we do it. There are two pieces, right? So they are broken down right here. So this piece, if you just look at this line itself, what is this line? This line is y equals to -1, negative x, right? Y is equals to negative x, the slope is equals to -1. This is y equals to x because the slope is positive. So we have y equals to x, one piece, or if you want to go from left and right, which is what I prefer, negative x and positive x, but this piece is when x is less than or equal to 0. This is when x greater than or equal to 0. Actually, we cannot use two equals simultaneously. And then what about this one? Absolute value of x plus 1. So this x plus 1, we have the plus 1 inside the absolute value. That means you have to shift the function absolute value of x 1 unit to the left. So this one we have two pieces. So the first piece is, so this piece we have the slope is negative, right? So we have let's do the positive one first. So this is y equals to x plus 1, right? The slope is equals to 1, and then the y-intercept is at positive 1. And then what about here? This one, if you go straight down, it will hit the -1. So that is y equals to x minus 1. Did I make a mistake? Yes, because the slope is negative. Another way to write this is you put a negative in front of the x plus 1. All right, so we have y equals to x plus 1 when x plus 1 is greater than or equal to 0. And then this is negative x plus 1 when x plus 1 is less than 0. And then we have to clean up the domain. So y is equals to x plus 1 and minus x minus 1. This is when x is less than -1. This is when x is greater than or equal to -1. And then the next one is a -2. The -2 is outside of the absolute value. That means you shift the absolute value function 2 units down. So we have y equals to x plus 2, right? Or actually, it's not x plus 2, it's x minus 2. X minus 2. So this is y equals to x minus 2, the piece on the right. And then the other one is also a -2, but we have negative x minus 2 because the slope is going downhill, is decreasing. So we have y equals to x minus 2 and negative x minus 2. Actually, have to close the parenthesis. Oh, come on. X minus 2. This is when x is greater than or equal to 0. This is when x is less than 0. And then we have y equals to x minus 2 when x is greater than or equal to 0, and then negative x minus 2 when x is less than 0. So that's how we write an absolute value function into a piecewise function. But that is not the purpose of this section. The purpose of this section is we want to find the limit with absolute value. This type of problem is really not fun. All right, I don't like this problem too much. So first step is you have to write the absolute value into piecewise. So number one, we have to write the absolute value of x minus 3 to two pieces. We have a x minus 3, we have a negative x minus 3. And then this is if x minus 3 is greater than or equal to 0. This is if x minus 3 is less than 0. One piece on the right side of 0, one piece on the left side of 0. And then you clean up the negative and the domain. So that is equal to x minus 3 minus x plus 3. This is a x add 3 on both sides. This one is add 3 on both sides. All right, and then you have 3 and minus 1 greater than and 1 less than, right? So this is like we have a 3. This, the greater than is on this side. Any value greater than 3 is on the right side, and then any value less than 3 is on the left side. So that creates a left limit and a right limit. So we have limit as x approaches to 3 from the right. Why do I put a plus right there? From the right. Which piece should I pick? X greater than 3. Then we have to put the piece where x is greater than or equal to 3. So do we just pick the x minus 3? No, you have to look at the function. There is a 2x in there. So you have 2x, and then you pick that piece, plus x minus 3. So fortunately, we can just plug in, right? So if you plug in the 3, you are not going to see anything dangerous like having a 0 in the denominator. So this you can just plug in a 3. So 2 times 3 plus 3 minus 3, that is equal to 6. And then limit as x approaches to 3 from the left. This is 2x, and then plus 3 from the left, and then you take this piece. So plus negative x plus 3. You can just plug in 2 times 3. Plus minus is a minus 3. And then plus 3. So that is equals to 6. So since they are equal, so the left limit and the right limit are equal, what does that mean? You have a point. You are not sure what is going to happen in here. Is this a solid circle or empty circle? You don't know. And then you check the limit. As x approaches to left from, as x approaches to x from the left. So this is your left side. X approaches to that number from the left is equal to x approaches to that number from the right. So you have left side equal to the right side. That means like driving. You have a car driving on this road and then stop right here. And then you have another car driving from this direction and then stop right here. So they both meet at this point. That means this is a solid point. A solid point means the limit as x approaches to 3, you have 2x plus the absolute value of x minus 3 is just equal to 6. This is my final answer. And then the next problem, we have another absolute value. And then this time the x approaches to 0.5 is from the left. Okay, so let's break the absolute value. So first, let's switch color to blue. The absolute value of 2x to the third minus x squared. So that is equal to, let's factor out x squared. X squared times 2x minus 1. Why do I have to do that? Because x squared is guaranteed positive. So you can factor out like this, x squared and then times 2x minus 1. So since it's guaranteed positive, we can just write that as a x squared and then absolute value of 2x minus 1. When you break, you only need to break the 2x minus 1. So you have a 2x minus 1 equals to 2 pieces. The first piece is 2x minus 1. The second piece, when I was learning algebra, all I will do is I multiply the entire thing with negative, just like the graph of absolute value of x. You have a positive piece, right? So the negative piece, the negative slope is you multiply the entire positive piece with negative. So we have negative 2x minus 1, and then this is if or when 2x minus 1 is greater than or equal to 0. This is a 2x minus 1 less than 0. And then you clean up the negative and the domain. So that is equal to 2x minus 1. And then if, so you solve the inequality, you add 1 on both sides and then divide it by 2. You have x greater than or equal to 0.5. Now I see why they put a 0.5 in the problem. And then negative 2x minus, no, plus, because you distribute the minus if x is less than 0.5. So going back to the problem, if you look at the problem, the limit right now, they have x approaches to 0.5 from the left. So 0.5, assuming this number is 0.5, 0.5 from the left is a number that is very close to 0.5, meaning that on the left side, we have a number that is less than 0.5. Think about this. This number must be less than 0.5, right? If it is greater than 0.5, then it is on the right side then. So when you evaluate the limit, you pick this piece only. You have limit x approaches to 0.5 from the left, 2x minus 1 divided by x squared minus 2x plus 1. Don't forget the x squared, so this x squared here. Don't forget. And then what do? Is there a problem when plugging a 0.5? I think there is a problem, right? Because half of 0.5, 2 times 0.5 is a negative 1. Negative 1 plus 1 is a 0. You have a plus right here, plus 1. So you do need to factor out the negative. So that is limit as x approaches to 0.5 from the left, 2x minus 1, and then you have a x squared. This, you factor out a negative 1. So you have a 2x minus 1. That is going to cancel the top, and then now you are safe to plug in. So you plug in a 0.5, 1 divided by 0.5 square, and then times negative 1. So that is equal to 1 divided by negative 0.25, so which is a negative 1/4. That is equal to negative 4. This is your answer. So that is how you solve a limit involving absolute values. You have to break the absolute value into piecewise function, and then depending on the left limit and the right limit, you have to decide which piece you have to use. So that is the trick. All right, we still have one more part to go. I will see you over there.